Hello everyone, this is Vinay Kumar from RC1080. I would like to give description about converter and HVDC system control. In general, HVDC system requires some control parameters. From this figure, it represents a HVDC single pole of an HVDC system. Here we can observe a supply side end and a load side end, which are both the AC system networks, and the supply end sine converter can be considered as a rectifier. Load side end converter can be considered as an inverter circuit. From this figure, if you want to consider current transmission in this particular HVDC system, ID can be represented as ID is equal to, by applying simple Ohm's law, as VD1 minus VD2 divided by the line resistance RD. It can be shows that the terminal voltage difference divided by line resistance gives the current transmission in the HVDC system. For instance, if you want to see the power transmission in this particular network, can be given as power P is equal to P in VD into ID. Now, if the power transmission is from converter 1 to converter 2, it should be in the direction from converter 1 to converter 2. Now, in some cases, there is maybe requirement of power transmission from load side end to supply side end, or the power reversal is possible if the direction of voltage terminal voltage is changed to reverse. In that instance, the power can be transformed from load side end to supply side end, in which case the converter VD2 is, the converter on the load side is considered as rectifier, and converter 1 should be worked as an inverter. So this circuit shows equivalent circuit of a DC transmission system with respect to, this is the rectifier part, and on the right side is the inverter part, and this shows as a line of the DC transmission system. The terminal voltages on rectifier end and inverter end, and with respect to these two terminal voltages, we can calculate the current in the transmission line ID. Whereas this RC1 and RC2 gives the representation for commutation resistances of the rectifier and inverter side respectively. When these two transmission networks, rectifier and inverter circuits, are considered, we need to analyze how much current is transmitting and what is the direction of power we require, whether that is from rectifier to inverter or from inverter to rectifier circuit. When we considering the desired features of control of a HVDC system, the first limitation of the maximum current so as to avoid damage to valves and other current carrying devices. That means the maximum current carrying by the devices or valves should be under control. The second limitation of the fluctuation of the current due to fluctuation of the alternating voltage. There may be chances of commutation failure as well in the cases of switching the valves. And also there is a requirement of prevention of arc back of the rectifier valves. And another important desired feature is to keep the voltage at the sending end of the line constant at its rated value. So it is possible in order to minimize the losses of a given power. The other important desired feature is controlling the power delivered, or in some cases the frequency at the one end. There are basically 4 reasons because of which we need to keep the power factor at high level. One is with respect to power of converter, which should be kept as high as possible. Another one is to reduce the stresses on the valves and damping circuits. The third reason is to minimize the required current rating and the copper losses in the AC lines to the converter. The fourth reason is to minimize the voltage drops at the terminals of the converter at its loading increases. So by considering these two transmission networks, that is rectifier to inverter, we can get the characteristics of the HVDC transmission line. Here we can see the curve between the constant voltage VD and ID. In order to get the constant power transmission from rectifier to inverter, we need to maintain a constant current, and which is represented by the line AB. In some cases, in practical cases, there may be possibility of reduction of voltage at the rectifier end or at the inverter end. In both the cases, the characteristics may be changing with respect to the lines representing CD and FG. So here, when these two cases maybe happens, it is required to maintain these characteristics constant by changing the values of inverter parameter, which is considered as constant extinction control. And this AB line represents a constant current control technique, and it also can be done on the rectifier side. So these two control characteristics can be obtained for the ideal HVDC transmission system. I conclude this converter control characteristics. Thank you. Thanks for watching the video. Thank you.